So today I want to talk to you about memoization. What's memoization? It's basically caching function calls in order to avoid the same computations happening over and over again with the same parameters. After implementing it several times in my code, I wondered if it's possible to implement it once and for all, like universally. In Python, once you have the decorator ready, it takes just one line to decorate the function. It looks like this. But as we now know, Python may take you up to several months to get your data. And besides that, it's a C++ conference, so let's do something comparably neat in our favorite language. I want to have a function, like the same that we have in Python, and take its name, specify the container I want to use, and just call these decorated versions with the same arguments. How are we going to do this? At first, let's talk about the container. Suppose that we have a function that takes arguments, returns a value. We create a key from the decayed arguments of that function and then use it as a key. The value is a value, and the suitable implementation of a container will look like this. So it's some kind of a hash map that supports two operations, set and get. Set updates the cache, get returns a pointer to the element if it's present, or a null pointer if it's not. And after Kate Gregory's talk this morning, I'm considering using instead optional, std optional. So now, once we have the container ready, let's think where it should be placed. Luckily, as we know, each instantiation of class or function template has its own static variables. So if we parameterize our decorator with a function, we can store the cache in a static variable. However, there is a problem with this approach. If we parameterize the template with the type of a function, which is basically its signature, we can run into collision if we want to decorate two functions having the same signature. However, there is a remedy to this problem. This thing looks weird if you see it for the first time, but it does a very useful thing. It allows us to parameterize templates with values rather than just types. Consider this example. We have a template of this form with a static function and a static variable inside that function. And what this function does, it just prints the address of the static variable. And we have three distinct instantiations with three distinct integers. And on my machine, this program outputs the following numbers. So the static variables inside are distinct. Okay. Let's build the decorator. We start with the template declaration. The first line of the parameters correspond to the trick I mentioned. The second line is about the container. Then we specialize our decorator for functions because we don't want to call the decorator on integers or strings or whatever. So first comes the function signature, then comes the function itself, and then the container we want to store our results in. Here where all the work is done, so the function call is supposed to be called instead of the function we are decorating. We have a cache stored in a static variable. We create key. We search our cache for an element with that key. If the result is present, we return it. If it's not, we call the function, populate the cache, and return the value. Okay, so how does the usages look like? They look like this. Our initial example looks just as neat as I want it to. And with decal type, I don't have to write by hand the function signature like back in the good old times. Okay, we can even decorate the recursive functions. So here's a Fibonacci example, and we just declare the function first and define it after we define the function that does all the work. Obviously, it's a simplification, and there is a lot of details left behind, like how does this thing interoperate with lambdas, std functions, std bind, what containers can we use to store the cache, the bunch of fancy hash maps to choose from. We can use LRU or whatever. How do we support concurrency? So how do we protect the access to the cache if the decorator is used in several threads? We can put simple mutex, we can use rvlock, we can even declare the cache thread local, so each thread has its own copy. So it's a work in progress, and I hope you'll hear more about it in the future. Thank you.